Okay, here we go. So, just wanted to show you a couple of things that's going to come up before tomorrow's lesson. And these methods will not be very confusing, Charlotte. They'll be very clear and straightforward and simple. So, we're going to start with factorizing. And I guess wanted to show you a couple of examples just to make sure we're all on the same page. So let's say I ask you to factorize something like this. That's a +2 there. Okay, and we want to know the greatest common factor. And I mean, at the end of the day, it all just comes down to understanding what this means, right? And this means literally 2 times itself n plus 2 times, whereas the other one is 2 times itself n times. So the greatest common factor there is 2 to the power of n. They both have n 2's in there. So this one there is 2 squared for the first one, left over, using index laws backwards. And then there's a 1 there. And I mean, that is factorized, but really I should work out that that's 5. So that is 5 lots of 2n. Okay? That's one example. Another example might be something like, what if I asked you to factorize 16 to the power of x minus 25? And you might say to yourself, you know, what do these things have in common at all or anything? And reasonable point, about to have a sip of drink, you can guess what it is. But the point is that these two things are both squares. 16 to the power of x is 4 to the power of x squared. Right? 25 is 5 squared. So this is 4 to the power of x minus 5, 4 to the power of x plus 5. And that might be useful for some reason, I don't know. Another example might be, what if I asked you to factorize something like this, and I'll just take the numbers out of the textbook to make sure it works reasonably well. Well, the point is again that 9 to the power of x is 3 to the power of x squared. So this is like a quadratic, right? It's basically x squared plus 4x plus 4. And that happens to be a perfect square. But instead of x, I've got 3 to the power of x. Okay, that's factorizing. Nice and easy. The one other thing I just wanted to talk about, and this again should probably be about the same level of time required. So exponential equations. So in other words, rather than factorizing, we want exponentials that equal something or other. So I'll start with a pretty straightforward one, pretty in pink. So let's say we've got 2 to the power of x equals 8. So I won't make any errors. The way you want to do these for now is basically make sure the bases are the same, right? We'll talk about something in a week or two, what we do when the bases aren't the same, right? But 8 is 2 cubed, right? So I can write equally that 2 to the power of x equals 2 cubed. And hopefully it's fairly obvious that in order for these two things to be the same, if the base is the same, the only way for them to be the same is also if the exponent is the same. So we get x cubed. Right? And that's, you know, we could do a couple more. So let's say I got 3 to the power of x equals 1/27th. Same idea. I know 27 is a nice power of 3, it's 3 cubed. But it's not quite the same because this one's on the top, this one's on the bottom. So I need to move it up to the top, and that will make it negative. And so therefore I get x equals minus 3. Same base, same exponent. The last one I'll do is, again, I'll just steal it from the textbook so the numbers are nice. So the problem here is I can't actually make 8 a power of 4, right? Because, I mean, realistically, we want to only do whole powers. We don't want to think about fractional powers. It's very hard to compute square roots and things in our head unless we know them already. But the pretty thing is, and it is very pretty, that 4 is actually a power of 2. And we know that 8 is also a power of 2. And now we're in business, right? We can apply the index laws. and then we solve an equation. Again, same base, so the powers must be the same. And we're finished. Okay. That's it for tonight. We'll just do practice on that tomorrow, and then the next day, we'll do practice on Wednesday, and then the next day we'll do fun stuff. Alright.